Hello everyone, this is lesson 4 of the chemistry of the atmosphere topics. Today's lesson is on common pollutants and their effects. Please can you make sure you've got your exercise books ready and a pen. I'd like you to write down the title, make sure you've underlined that, and then answer the do now in your books please. The question is, what is the most common cause of atmospheric pollution? And the extension is, what effects could these have on your health? So can you please pause the video and answer that question, then we'll go through the answer together. Okay, so for the do now question, the main question, what is the most common cause of atmospheric pollution? I'm guessing that a lot of you probably have written down the combustion or burning of fossil fuels. This is correct, this is the most common cause. And we're thinking of factories, so where we've got industry, so burning fossil fuels in industry, and the effects that these could have on your health. You might have written down a respiratory issue, so a problem with your lungs, breathing in the pollutants. This would be correct. You might not have thought of things like, so lung disease can be an issue, heart disease, strokes, so cancer can be an issue from some of these, the health effects from these pollutants as well. Okay, so we're going to talk in more detail about these common pollutants in this lesson. The key words are in the corner of this presentation if you wanted to write those down. The lesson objectives are describe and explain how atmospheric pollutants are produced and the problems they cause, and predict the products of complete and incomplete combustion. Okay, so what you can see now on the screen is we've got pictures of Bunsen burners. So when we burn fuels, we've got the generic equation, okay? So we've got fuel plus oxygen, so that's whatever fuel it is, it doesn't matter, gives you carbon dioxide and water. When we talk about burning fossil fuels, we're talking about hydrocarbons. So have a think about what elements could be in a hydrocarbon. So hydrogen and carbon are the only two elements in a hydrocarbon. But what you have is different amounts of each of those elements to make different hydrocarbons. Can you please write down the general equation? This is the equation for complete combustion. And that means that there's been a full reaction. So if you copy that down and think about what happens when we're thinking of a Bunsen burner, what happens in complete combustion because the hole is open? Why would that happen? Okay, so what's happening? So the reason we've got complete combustion when the hole is open in the Bunsen burner is because there's enough oxygen for all the fuel to react. So we've got the hydrocarbon, which is a fuel, carbon and hydrogen, are fully reacting and they're both oxidized. So carbon is oxidized to form carbon dioxide and hydrogen is oxidized to form water. So can you please make sure you've got that written in your books as well so that you understand what complete combustion means. So when we're looking at incomplete combustion, again, we can think about our Bunsen burner. So here, the general equation for you to write down, please, is fuel and oxygen. So again, we've got our hydrocarbon there and plus our oxygen. And that gives us some different products. It gives us carbon, and we've got soot in brackets there. It's important you write that down. Carbon monoxide and water. I want you to have a little think about what carbon monoxide is. You should have all heard of it. And remember, we know to do with the word equation how many of certain elements are in there. So carbon monoxide, so remember that means one. So we've got a carbon and a one oxygen, which gives us carbon monoxide. You might have heard of it as being the silent killer. So carbon monoxide is really dangerous. When we have incomplete combustion, and that's one of the products, carbon monoxide can actually kill. So what happens with carbon monoxide is that it can bind with the hemoglobin in your blood, and it means that not enough oxygen is carried around the body. We can talk about that again in a bit when we're talking about carbon monoxide in more detail. So incomplete combustion happens when the hole is closed. Why is this? So the difference between the complete combustion and incomplete is that not enough oxygen is involved in the reaction. So there's not enough for the fuel to fully react. So carbon and hydrogen aren't fully oxidized in this. And then what you get is carbon soot. So you're actually getting solid particles, carbon monoxide gas, and water is still one of the products, but we've got a few nasty products there as well. Please make sure you've got that written into your books. Okay, so what you need to be able to do is write down or know the products of full and complete combustion. Okay, so if we have a complete combustion equation, there's some examples for you to write down. So for example, methane and oxygen would give you the products of carbon dioxide and water if it's fully combusted. So we've got a word equation here, but in brackets, you can see the symbol equation. So we know that it's just got carbon and hydrogen in it for a hydrocarbon, but you've got one carbon atom and 4 hydrogen atoms. But for the word equation, it's exactly the same products. And again, we've got ethane and oxygen, so a different hydrocarbon, gives you carbon dioxide and water. So exactly the same products, even though they have different amounts of carbon and hydrogen in them. You need to be aware of this word equation. You might be asked to complete the word equation for complete combustion. So what I'd like you to do now is in your books or on your piece of paper, you are going to copy down. So copy the examples, please, and also the task. You're going to write down the different hydrocarbons, okay, plus oxygen, and you're going to write down what products they give you. So we're going to go through the answers for this. Can you please make sure you're marking your work? So what you should have had is for full or complete combustion equations, you always end up with carbon dioxide and water, regardless of what the hydrocarbon is, like I said earlier. So you should have exactly the same products. The difference would be if it was a symbol equation and you were asked to put the products in, but also balance the equation. So if you look at the different hydrocarbons, you can see they have different amounts of carbon and hydrogen atoms. So when you balanced it, you would have a different number of carbon dioxide and water molecules. So it would just be the difference in that there. So when you burn fossil fuels, we don't always have complete combustion. So we talked about incomplete combustion. And we can also have other things that are produced, other products that are produced that can be quite nasty. So we're going to talk about some different pollutants. I'd like you to draw the table below in your books. So with this one, you're going to write down the pollutant. So we've got oxides of nitrogen, sulfur dioxides, carbon monoxide, which we talked about briefly, and carbon particles, which we've also talked about briefly. So you're going to write down how this is formed and problems that it causes. And can you see you've also got some words and sentences which you need to fill out the table with, please. Okay, so can you draw that in your book and fill it out? Pause the video and then we'll go through the answers. Okay, so we're going to go through the answers. So can you please make sure you have got these answers for your table? So can you mark them and correct them if you had any wrong? So we're going to talk through each of the pollutant, how it's formed and the problems it causes in a bit more detail. So oxides of nitrogen, they tend to be two examples of them, a nitric oxide and nitrogen dioxide. So what happens with these, with the burning of the fossil fuels, the heat causes a reaction between the nitrogen and oxygen in the air, and then we get these oxides of nitrogen. There tends to be more of these in areas with higher levels of pollution, generally through, because it can be created, oxides of nitrogen can happen in the internal combustion of cars as well. So they're formed by burning, and the problems that they can cause are acid rain, but also problems to your health as well. We're going to talk about that with sulfur dioxides because they can also cause the same issues. So fossil fuels can have sulfur impurities in them. And When these are burnt, we then get, so this happens when the fossil fuels are burnt, we get these sulfur dioxides, again, a reaction between the sulfur and the oxygen from burning. So again, we get this acid rain issue. You should have all heard of acid rain. What can happen is it can damage buildings, statues, it can corrode metals. Okay, there can also be issues with so health problems due to acid rain, so respiratory problems. Also, they can kill plants. So there's quite a few problems here from these oxides and dioxides. We've already talked about carbon monoxide. This is formed through incomplete combustion. So remember, it's a product from incomplete combustion. So we've talked about how the reason it can cause death is because the carbon monoxide binds to the hemoglobin in the blood. And this prevents the blood from carrying around oxygen, and it can cause death because of that. So the reason it's called the silent killer is because carbon monoxide gas is odorless and colourless. So anything that that's run by fuel has the unfortunate, it could cause carbon monoxide poisoning due to incomplete combustion. So that's why it's so important that we have these checks on certain things, like boiler checks, and anything that uses fossil fuels in order to give us then sort of heat or anything in the house. So another issue that we talked about was from incomplete combustion, you could have soot or carbon particles, also called particulates. These are solid. They can cause dirty buildings. They can also cause global dimming. So global dimming is when the light reflects from these carbon particles away from the Earth. And that prevents light from reaching the Earth. So that can be a real issue. And also the carbon particles can be breathed in. They can cause respiratory issues in the lungs as well. So there is a test that can be to check for sulfur dioxide in fossil fuels. So the fossil fuel is burnt and the gases produced from the fossil fuel are bubbled through a solution. So if sulfur impurities are present, then sulfur dioxide will be formed. And then sulfuric acid will be formed, which will then turn the universal indicator in the solution red. That's a test that can be performed to see if there are a lot of impurities in fossil fuels. We shared a Google form for you to complete. This is a question, some exam questions on the topic we've covered today. Please can you complete those by the deadline and submit them to your teacher, and also upload your notes from this lesson for them to see. Okay, take care everyone, stay safe.